Hello students, in the previous lecture we have studied about power of accommodation. Means human eye lens can accommodate to focus near as well as far objects clearly, but sometimes eye gradually lose its power of accommodation. In such conditions the person cannot see the objects clearly and distinctly. This is known as defect of vision. So there are three common defects of vision which can be corrected by spherical lenses. These defects are myopia, hypermetropia and presbyopia. Today we are going to discuss the first defect of vision, that is myopia. So let's start with the first defect of human eye, that is myopia or short-sightedness. It is also known as nearsightedness. Now, what is myopia? Myopia is that defect in which a person can see near objects clearly, but he is not able to cannot see far objects clearly. Fine. So it is a defect in which the person can see near objects clearly, but the far object or distant objects are blurred in that case. Fine. So for a myopic eye, the far point is not infinity. Remember this thing. We know that for a normal eye, far point is infinity, but for a myopic eye, the far point is not infinity. Fine. So suppose the far point of the myopic eye is O, which is lying at a distance x from the lens. So a myopic person can see the objects that are situated between this distance x to 25 centimeter. Fine, because 25 centimeter is the near point of a normal eye. Fine. So the objects that are situated away from this object, this far point O, that are not clear to the myopic person. Fine. Suppose this O dash is the object. Fine. The light rays are coming from a distant object that is farther from the far point O. In that case, the light rays will converge before the retina. Fine. A person can see objects clearly when the light rays converge at retina, but in this case the light rays converge before or in front of retina. So a myopic person will not be able to see this object clearly. Fine. Now, what are the causes of myopia? So the first cause is, that is excessive curvature of eye lens. Fine. So the excessive curvature of the eye lens, which results in decrease of focal length. Fine. So the first cause is excessive curvature, results decrease of focal length. Fine. Second is the elongation of eyeball. Fine. Means the distance from the lens to the retina increases. This distance increases, hence the image form between lens and retina, in front of the retina. So these two are the causes of myopia. Fine. So how can we correct this defect? Means correctness. We can correct this myopic defect by using a concave lens of suitable power. Fine, suitable power, or you can say suitable focal length. Fine. Now this concave lens forms a virtual image of this object at the far point O. Fine, I am repeating again that this concave lens forms a virtual image of this object O dash at the far point O. Fine. So if it forms a virtual image at O, in that case the image of this object, which is virtual image of this object, will form image on the retina. Is that clear? It forms image on the retina. I am repeating again, the myopic defect can be corrected by a concave lens of suitable power. So the concave lens forms a virtual image of distant object at the far point of a myopic eye. So the light rays that are diverging from this point O are now focused at retina. So the person can see this object clearly. Clear? So we need to remember three things. First, what is defect? A person can see near objects clearly, but the far or the distant objects are blurred in that case. Second is, what is the cause of myopia? First one is excessive curvature, results in decrease of focal length of the eye lens. Second one is elongation of this eyeball. Elongation means the distance between the lens to the retina increases. And this defect can be corrected by a concave lens of suitable power. Clear? Thank you. Hello students. In the previous lecture, we have studied about the human eye defect called myopia or short-sightedness. Fine. Today, our topic is hypermetropia or long-sightedness, or it is also known as far-sightedness. Now, what is hypermetropia? It is the human eye defect in which a person can see far objects clearly. Means in this defect the person can see the long distant objects or far objects clearly, but can't see near objects clearly. Fine. So hypermetropia or the long-sightedness is the defect in which the person can see far objects clearly, but the near objects he is not able to see clearly. Fine. So what is the cause of this hypermetropia? What is the cause of this long-sightedness? In this case of hypermetropia, the far point is infinity. Fine. But the near point is not 25 centimeter. Means in this case the near point shifted away from the 25 centimeter. Means suppose for the hypermetropic eye the near point is n. Means suppose this is x. Fine. And this x is greater than 25 centimeter. Clear? So in the hypermetropia the near point shifted away from 25 centimeter. Clear? Now if the object is placed at 25 centimeter, means this object is placed at 25 centimeter, means D or least distance of distinct vision, means at 25 centimeter. In that case the image will not form at retina. Fine. The image will form behind the retina. So the image will not be clear for hypermetropic eye. Clear? Now, what are the causes of hypermetropia? So the first cause is the curvature of eye lens is too small. Means the curvature of eye lens is small, which results increase in focal length. I am repeating again, the curvature of eye lens is small, which results in increase in focal length. So the focal length of this eye lens increases. That's why the image form behind the retina. Fine. Second cause is shortening of eyeball. Means this eyeball, the size of this eyeball decreases. So the shortening of eyeball is the cause of this hypermetropic eye. Clear? Now, what is the correctness of this defect? How can we correct this defect called hypermetropia? Fine. This defect can be corrected by a convex lens or converging lens. Means we need a lens which converge the light rays at retina. So we can use a convex lens or converging lens of suitable power. Clear? Now what happens in this case? Suppose we use a convex lens of appropriate power for this hypermetropic eye. So the image, the virtual image of this object which is placed at the 25 centimeter, means the near point of a normal eye. In that case, this convex lens forms a virtual image at n, means the near point of hypermetropic eye. Fine. So if this lens forms a virtual image of this object on the near point of this hypermetropic eye, in that case the light rays will converge at retina only. So by using a convex lens or converging lens of suitable power, we can correct this hypermetropia. Fine. I am repeating again. Hypermetropia is the defect in which the person can see far objects clearly but can't see the near objects clearly. In this case, the far point is infinity, but near point is not 25 centimeter. Fine, it's greater than 25 centimeter. Fine. Now, what are the causes of hypermetropia? First one is the curvature is too small of eye lens, which results increase in focal length. Second one is the shortening of this eyeball. Now, last is correctness. How can we correct this defect? This defect can be corrected by a convex lens or a converging lens. This converging lens forms a virtual image of this object on the near point of this hypermetropic eye, so that the image converge on the retina. So the person can see the object, the image of the object clearly. Clear? So the next defect is presbyopia. Now what is presbyopia? Now with increase in age, the flexibility of eye lens gradually decreases. Fine. With increase in age, the flexibility of the eye lens decreases Also, the ciliary muscles becomes weak. Fine. So the flexibility of eyelids decreases and the ciliary muscles become weak. As a result, the power of accommodation of eye decreases. Fine. With increase in age, the flexibility of eyelids decreases. Also, the ciliary muscles become weak. Therefore, the power of accommodation of the eye decreases. Fine. So, the people find difficulty in focusing the near objects. So the person in old age find difficulty in focusing the near objects clearly. Fine. So this defect, this old age defect is known as presbyopia, in which the old age person finds difficulty in focusing the near objects. Fine. Because the flexibility of eyelids decreases and the ciliary muscles become weak. Fine. So this defect is corrected by convex lens. Fine. So presbyopia is same like hypermetropia, but the cause is different. The cause is old age, weakening of muscles. Fine. Flexibility of eyelids decreases. But in some cases, person cannot see near objects as well as far objects clearly. Means old age person find difficulty in focusing near objects as well as far objects clearly. Fine. So this is also known as presbyopia. In this case, the person with presbyopia use bifocal lens. So bifocal lens is used in correcting presbyopia if the person finds difficulty in focusing near as well as far objects. Fine. So for example, here is your bifocal lens. The upper part of this bifocal lens used in myopia, means to see the far objects clearly, and the lower portion is used for hypermetropia, means to focus the near objects clearly. Fine. I am repeating again. Presbyopia is an old age defect. With increase in age, the ciliary muscles become weak. So the flexibility of eyelids decreases. So the person finds difficulty in focusing the near objects clearly. So in that case, the person can use convex lens. But sometimes person cannot see near objects as well as far objects clearly. Fine. In that case, the person will use bifocal lens. Fine. Bifocal lens means the upper part of the bifocal lens is a concave lens. It is a concave lens used to correct myopia, and the lower part is convex lens used to correct hypermetropia. Clear? Thank you. Hello students, in this lecture we are going to study how to calculate focal length and power of lens to correct the defect of human eye. Fine. In this we have two type of numericals. first is the case of myopia and second is the case for hypermetropia. Fine. Now you need to remember 2 points to solve the numericals for focal length and power of lens for the defects of human eye. We know that the lens formula is 1 by V minus 1 upon U is equals to 1 upon F, where V is the image distance, U is object distance and F is focal length. Fine. You need to remember in the case of myopia, the value of U is minus infinity. Fine. And the value of V is equals to minus X, where X is the far point of myopic eye. I'm repeating again, X is the distance of far point of myopic eye. Fine. Now putting these values in this equation, we have 1 upon minus X minus 1 upon minus infinity is equals to 1 upon F. So 1 by infinity becomes 0. Fine. So it becomes minus 1 upon X is equals to 1 upon F. Fine. So F becomes minus X. So the value of X with negative sign will give you the focal length of concave lens that is going to use in myopia. Clear? Now to calculate power of the lens, we have formula power is equals to 1 upon F in meters. Clear? Or you can say it is 1 upon minus X in meters. Right? So by using this formula, we can find the value of focal length and the power of lens. Clear? Now let us discuss the case of hypermetropia. Again using the formula, lens formula, that is 1 by V minus 1 upon U is equals to 1 upon F. Fine. Now in the case of hypermetropia, the value of U is equals to minus 25 centimeter. Fine. That is the near point of normal eye. Fine. And the value of D, the value of V becomes, and the value of V is minus X. Fine. The value of, I'm repeating again, the value of U is minus 25 centimeter. That is the near point or least distance of distinct vision, and the value of V is minus X. That is the near point of the defected eye. Fine. Now putting these values, we have 1 upon minus X minus 1 upon minus 25 is equals to 1 upon F. So the formula becomes minus 1 upon X plus 1 upon 25 is equals to 1 upon F. Fine. From this formula, we can calculate the value of focal length. Again using the formula P is equals to 1 upon F in meters, we can calculate the value of power of lens that is going to use in hypermetropia. Clear? Now let us solve one numerical that is based on myopia. Fine. Now the question is, the far point of myopic eye of a person is 2 meter. Fine. In front of the eye, what is the nature and power of lens required to correct this defect? Fine. We know that in the case of myopia, 1 by V minus 1 upon U is equals to 1 upon F. Fine. The value of U is minus infinity. Fine. And the value of V, that is minus X, the value of X is 2 meters. So it becomes minus 2 meter. Fine. Now put this value in this equation. We have 1 upon minus 2 minus 1 upon minus infinity is equals to 1 upon F. So it becomes minus 1 upon 2 is equals to 1 upon F, because 1 upon infinity is 0. Fine. Reciprocal it, so it becomes F is equals to minus 2 meter. So the focal length of the lens is minus 2 meter. Fine. Now to calculate power of lens, that is 1 upon f in meters. Fine. The value of focal length is in meter. Fine. So you can use 1 upon f. The value of f is minus 2. So it becomes minus 1 upon 2, which is equals to minus 0.5 diopter. So the power of the lens is minus 0.5 diopter. Now look, the sign is negative. Fine. If the power of the lens is negative, this indicates the corrective lens that we are going to use in this numerical to correct the defect of human eye, that is concave lens. Fine, because the power of concave lens is negative. Clear? Now the next question is, the near point of a hypermetropic eye is 0.5 meters. Fine, means the value of V, means near point of hypermetropic eye is 0.5 meter, or you can say 50 centimeters. Fine, find the power of lens required to correct this defect, given that the near point of normal eye is 0.25 meters, means the value of U, which is equals to minus D, which is minus 0.25 meter, which is equals to minus 25 centimeters. Clear? So the value of V is also negative. Fine. So V is minus 50 centimeter, the value of U is minus 25 centimeter. Using lens formula, 1 by V minus 1 upon U is equals to 1 upon F. Fine. The value of V is minus 50 minus the value of U is 1 upon minus 25 is equals to 1 upon F. Fine. So it becomes minus 1 by 50 plus 1 upon 25 is equals to 1 upon F. Fine. Or by taking LCM, 50 minus 1 plus 2 is equals to 1 upon F. Fine. So 1 upon F becomes 1 upon 50. Clear? So the value of F becomes 50 centimeters, which is equals to 0.5 meter. Fine. So the value of F is 0.5 meter. Clear? Now to calculate the power of lens, we have formula P is equals to 1 upon F in meters. Fine. So the value of F is 0.5. It becomes 1 upon 0.5, which is equals to plus 2 diopters. Fine. So the power of the lens required is plus 2 diopter. So this plus sign indicates the lens required is convex or converging lens. Fine. So by using these formulas, we can calculate the power of lens required to correct the defect of human eye. Clear? Thank you.